So, welcome back to the course on blockchain. In the last lecture, we have discussed about this Bitcoin mining procedure, and we have looked into the consensus protocol in permissioned blockchain environment with a focus to the proof of work based system in Bitcoin network. And we have looked into that how this proof of work based mining procedure it generates a consensus mechanism among the different miners who are proposing new blocks and make a tamper proof architecture of the entire blockchain. So, in today's lecture we will explore that further and we will look into the different tasks of the miner and what are the incentives to the miner to participate in this mining procedure, and that mining procedure how motivate them to employ some kind of economical properties or economical feature in the environment to control the entire mining procedure. So, let us look into the details of the Bitcoin miners. So, so the life of a miner of something like this. So, their task is to validate the transaction and then construct a new block. Once they have constructed a new block, then employ their hash power to vote on consensus. Vote on consensus in the sense like to find out that who is going to complete the work first, and then accordingly propose that block as a new block and commit the transactions in that new block and add that new block to the existing blockchain, and then store and broadcast that new blockchain to the peers. So, that way the entire blockchain gets propagated in the network. So, this mining Bitcoin, the entire procedure has 6 different steps. So, the first step is that if you want to be a miner, you have to join in the Bitcoin network and listen for the transactions, then validate the proposed transactions which are coming from the client. So, the next step is to listen for the new blocks, validate those new blocks and rebroadcast a new block when it is proposed. So, if you are getting a new block from one of your peer, then you validate that new block and rebroadcast it in the network. Then collect the transactions for a predefined time and construct a new block with that transactions, the transactions which are not already included in the blockchain. So, as a miner you take those transactions and construct the new block. Then your task is to participate in the mining procedure, where your task is to find out a nonce to make the block valid by utilizing the predefined difficulty function for that. That means having certain minimum number of zeros at the prefix of the obtained hash value. So, you have to generate the nonce according to that, which is the mining procedure. So, once you have got a new block, you broadcast that new block to your peers, and everybody in your peering system, they will accept that block if it is part of the main chain. So, this concept we have discussed earlier, because in a typical blockchain environment it may happen that multiple blocks are generated together. So, you had a block earlier. So, assume that this is the blockchain, this is the longest chain, every block is pointing to the previous block by the nonce, and then at this. So, this is at time instance t1, this is at time instance t2, this is at time instance t3, and then at time instance t4 two miners have found out a same block. If two miners have found out a same block and both are the valid blocks, then they propose those blocks to the peers, and if both are valid block, they gets propagated. So, the idea is here I am just trying to draw a Bitcoin network where you have multiple peers. Now, assume that this is one miner and this is another miner. So, this miner has a found out block. I am naming this block as B1, B2, B3, B4 and B5. So, this miner has found out block B4, this miner has found out block B5. So, this miner will broadcast this B4 block to its peers, then this peer will again broadcast this B4 block. Similarly, this particular miner it will start broadcasting B5 block, and this intermediate node it will get certain number of B4 blocks and certain number of B5 blocks. So, it will accept the block which it has received from more number of peers. So, it has say 1, 2, 3, 4, 5 different peers. So, if it receives B5 from, say it has received B5 from 3 peers and it has received B4 from 2 peers, then this miner it will accept the block that it has received from maximum number of peers and rebroadcast that block. So, that way the next block say which is getting generated, say B6, it is say B5 is now getting propagated, and this miner it has say this miner it has received this miner it has received the block B5, it has accepted block B5, and after accepting block B5 it has got successful in generating block B6. Now, it adds up this block B6 with B5. So, now at instance T5. So, now this becomes B1, B2, B3, B5, B6, this becomes the longest chain in the network, and this particular blockchain is utilized, and the additional block that we had earlier we call this is a fork, and this particular block it is not getting added further. So, these blocks are not become the part of the main chain. So, this chain is termed as the main chain, this is termed as the main chain in the blockchain network, and this block B4 it the block B4 it does not become part of this main chain. So, we call this block as the orphan block. So, that way the entire blockchain gets propagated in the network. Okay. So, this way the block get broadcasted in the network, and whenever the miner has found out a new block by participating in the mining procedure, they earn certain reward for participating in the mining procedure, and this individual thing runs in different rounds. So, at every time instance you are generating new blocks one after another. Now, we have a term called mining difficulty. So, this mining difficulty it is a measure of how difficult it is to find a hash below a given target. So, it should be fine to find a hash below a given target. So, if you remember the mining procedure says that we are going to generate a 256 bit hash function, and we say that there is a mining difficulty. The difficulty represented in this way that well, out of this 256 bit hash, the first 64 bit should be 0. So, at least first 64 bit would be 0. So, this says that well, you have to generate a hash function where in the final hash result at least first 64 bit should be 0, and after that the remaining bits can be zeros and ones. So, this is the difficulty of the mining procedure, and based on that we define a metric called mining difficulty. So, we have a concept called mining pool that we will discuss later. The mining pools also have a pool specific share difficulty. Now, this difficulty parameter I am going to discuss the mathematical formulation of this difficulty parameter. So, this difficulty parameter it changes for every 2016 blocks. So, our desired rate is that we want to generate one block each at 10 minutes. So, at every 10 minutes my target is to generate a new block. Now, if you try to generate a new block at every 10 minutes and if you do the computation in that way, you will find out that well, to generate 2016 blocks, you require exactly 2 weeks. So, within 2 weeks you can generate 2016 blocks. So, this difficulty level, it is readjusted at every 2 weeks. So, at every 2 weeks you find out that how many blocks you have generated, whether you have generated 2016 blocks in less than 2 weeks time of duration, then that means the difficulty is going to be too simple for the miners. So, you increase the difficulty, and if you finding out that well the miners are taking more than 2 weeks of duration to generate 2016 blocks, then it means that current difficulty is going to be too hard for the miners. So, you reduce the difficulty in that way. So, with this idea in mind, so we define difficulty, or we set the difficulty by utilizing this formula. So, you compute the difficulty at every 2 weeks, or you can just recompute the difficulty after every 2016 blocks have been generated. So, you can compute it on either every 2 weeks or after 2016 blocks are generated. So, our expectation is that within 2 weeks we want to generate 2016 blocks. So, that inter block generation time becomes equal to 10 minutes. So, we set the difficulty in this way. So, the current difficulty will be previous difficulty, the difficulty that was earlier, multiplied by 2 weeks in millisecond, the total 2 weeks duration, divided by milliseconds to mine the last 2016 blocks. So, that means if you are taking less time to mine 2016 blocks compared to 2 weeks, then you are going to increase the current difficulty. So, if you can generate 2016 block faster, that means the current difficulty is going to be too easy for the miner. So, you increase the difficulty level. If you are taking more time compared to 2 weeks to generate these 2016 blocks, that means this time this milliseconds to mine last 2016 blocks, this terminology becomes more than 2 weeks equivalent in millisecond. If you are taking more time than 2 weeks, that means the mining is becoming too hard. So, you reduce the current difficulty level. So, that way the Bitcoin network dynamically changes the difficulty level. Now, let us look into that how this difficulty level is related to the hash rate. That means, how many hash you can perform. Now, the hash that we are going to generate, as you are using double SHA-256 for generating the hash function. So, this hash is a random number between 0 and 2 to the power 256 minus 1. So, to find a block, our objective is the hash must be less than a given target. So, we offset the difficulty level 1 as 0 FFFF into 2 to the power 208. That means, out of the 256 blocks, we are saying that the initial 48 bits we want as the 0, and the remaining bit we want as the 1. So, that is the offset for difficulty 1. Now, accordingly we define the offset for difficulty D is all ones into 2 to the power 208 divided by D. So, this many number of zeros for different values of D. By doing this computation, you can find out that how many zeros you want at the beginning. That determines the number of zeros that you want at the beginning. The example that I have given for difficulty level 1. So, for difficulty level 1, we want that the 208 bits. So, out of this 256 bit hash, the 208 bits should be equal to can be either 1 or 0. Okay. So, we have a control over this 48 bit. We want that this initial 48 bit should be all zeros. So, that is for the difficulty level 1. Accordingly, we define the difficulty level D, the number of initial bits that we want. So, the expected number of hashes we need to calculate to find a block with difficulty D is something equal to D into 2 to the power 256 divided by this offset. So, that means it comes to be d into 2 to the power 48 divided by this offset value. So, that is the expected number of hashes that you need to perform. So, this difficulty level dynamically changes the amount of hash that you want to do. So, if you are providing more difficulty, that then, so if you increase the value of d, if you are providing more difficulty value, so you have to generate more number of hashes to get the resultant target. Well, so this is the current mining difficulty as of 2nd April 2018. So this large number represents the current difficulty level for a blockchain network, for a Bitcoin network. Okay. So, if you look into that how difficulty level has changed over time, so this curve gives you that how the difficulty level changes got changed over time. So, you can see that mostly from January 15 to the current time, we have a sharp increase in the difficulty level. So, later on we will see that presently more and more miners are coming with higher hardware or high power hardwares to mine the blocks. So, that way the mining has become more faster nowadays. So, to control that the Bitcoin network has gradually increased the difficulty, and we can see a certain sharp increase in the difficulty level in the last few months, where a large number of miners have participated in the mining procedure with specialized mining hardwares. So, as I have mentioned, there are multiple specialized mining hardwares which are available nowadays in the market. So, initially people have started doing the mining on the standard computer, then they have find out that well, by participating in the Bitcoin mining procedure you can get more benefit, you can get more reward and you can earn Bitcoin. So, the miners they have started developing hardwares for that, and initially people have moved from the CPU based hardware to the graphic processing unit GPU based hardwares, and gradually recently they have moved to the hardware based on FPGA boards. So, this diagram actually shows you hardware with multiple FPGA boards. So, then in 2013 so we had this ASIC based mining hardware. The full form is of ASIC is application specific integrated circuit. So, this ASIC was designed to perform this SHA-256 hash in a faster way. So, if you remember that in Bitcoin mining procedure we apply SHA-256 bit hash function. So, to increase the mining speed, what you have to do that you have to generate more number of hashes per unit time. So, this ASIC the first ASIC was released in 2013 for this fast computation of SHA-256 based bit hash function, and this diagram is for a mining hardware corresponds to this ASIC design. So, here is an use case which we called as the TerraMiner 4. So, this TerraMiner 4 is a ASIC based Bitcoin mining rig which has multiple such FPGA boards inbuilt, which can perform fast computation of hash function. It can perform 2 terahash per second, that many number of hash it can perform. So, you can imagine that how many number of such 256 bit SHA-256 hash function it can perform, and the current cost for this hardware is approximately $3,500 US. But nowadays even this hardware is not sufficient. People have started building up mining pool or combination of multiple hardwares together to perform these mining operations. Well, the point that I mentioned, that the mining pool it is an interesting concept in blockchain network and Bitcoin network. So, the idea of this mining pool is that you combine multiple miners together, the resources available from multiple miners together, and then you ask the miner to generate the hash in a distributed way. So, every miner will start to generate the hash for a block, and they will basically share their processing power over the network to mine a new block. So, the broad idea can be explained with an example. So, let me show you an example of that. So, you have a pool controller, or sometime we call it as pool organizer, whose task is to construct or propose a new block. So, the pool organizer say has constructed a new block with multiple transactions, and the task could be, so this is a new block that has been constructed by the pool organizer, and the pool organizer has constructed the new block, and the task is to find out the nonce for this block. Now, there are multiple miners, say M1, M2, M3 and M4. So, you have multiple miners. So, the pool organizer informs this new block to all the miners and asks them to find out the hash value corresponds to that. Now, what happens? Every miner independently tries to find out this nonce value, and whenever they are finding out the nonce value, say assume that the current difficulty level asks for say 20 leading zeros, 20 leading zeros at the prefix. Say this is the current mining difficulty. If this is the current mining difficulty, then what individual miner can do, they can try to find out the hash value where there are approximately 20 leading zeros at the prefix. So, the miners can propose something called a share. So, what is a share here? Like whenever the miners are generating the blocks, the miners will generate blocks something like, say they can generate the block something like 2D, 5, 6, something like that. Here I do not have 20 leading zeros. So, this is in hex. So, this 4 zeros signifies for 16 leading zeros. So, in this case, this is a kind of, we call this kind of hashes as a near optimal hash. So, these are kind of near optimal hash. So, this near optimal hash ensures that, well, this particular block is not the optimal one that is intended for, but this particular miner is close to optimal. So, that way this miner also forwards this near optimal blocks to the pool organizer as well as the block which is optimal. So, if the miner can find out a hash, one of the miner can find out a hash where you have at least 20 leading zeros, I should mention it as at least 20 leading zeros at the prefix, then that is the solution. So, assume that M2 were able to find out such a block, and M2 is sharing this block with pool organizer, and M3 was able to find out 3 such near optimal hash values which are closer to the original hash value, and M4 was able to find out 2 such hash value. So, the idea is that the way they have participated in this mining procedure. So, whenever all these 4 miners, they are trying to collectively find out the nonce value for a single block, the probability that one of them will be able to find it out, it becomes higher compared to if a single miner tries to find out the hash value for the entire block. So, that way this mining pool concept, it can increases the probability of getting a new block, and at the same time these near optimal solutions that every miner is sharing with the pool organizer, from this near optimal solution the pool organizer can decide that how much work has been done by individual miners. So, this miner was able to send 2 such near optimal solution. So, the idea is that whenever you are paying to this miner, you say pay 5 say $2 to this miner. This miner was able to generate 1 near optimal solution. So, you pay $1 to this miner. This one was able to generate 3 near optimal solution. So, you pay $3 to this one able to generate 2 near optimal solution. So, you pay $2 to this miner. So, that way the total block reward that the pool organizer is getting, that particular block reward can be shared by multiple miners who are participating in the mining pool. Okay. So, that is the broad concept of mining pool, and here is a distribution of multiple pools which are there in the today's Bitcoin network. So, this BTC.com and pool, BTC.top via BTC, they actually takes a huge share of the mining pool, and one of the interesting statistics that I can show you. So, well, in this blockchain.info website, you can see you can see the latest blocks which are being generated by multiple miners who have actually generated the block, and this is the height of the block. So, currently the Bitcoin blockchain has this many number of blocks, 516279 number of blocks. So, if I go to see more, so you can see all the blocks here. So, you can find out that most of these blocks are relayed by some of the mining pools. So, this block was relayed by BTC.top, then BTC.com, then via BTC, then via BTC, BTC.com, via BTC. So, you can see that via BTC has relayed this 1, 2, 3 block, BTC.com has relayed this block, sorry, not this block, BTC.com has relayed this block, then again this block. So, that means most of the blocks have been generated by some of the some of the mining pools. So, they are collectively able to generate the new blocks and share the money among themselves. Okay. So, let us look into that how the shares are distributed among different miners in a mining pool. So, in a mining pool there can be hundreds or thousands of miners who communicate with each other through some special protocols that I have discussed earlier. So, assume that capital B is the block reward minus pool free. So, every pool has, whenever you are participating to some mining pool, you have to give some fee for that, and B is the block reward minus the pool fee, the effective reward that you are getting, and P is the probability of finding a block in a shared atom whenever multiple miners are trying to do that. And if D is the block difficulties, then we can say that 1 by D is the probability for finding a block. Now, we have multiple mechanism like for distributing the share. One is called the paper share. In paper share architecture, you have instant guaranteed payout to a miner. So, whenever a miner is joining in the mining pool, you pay the miner from the pool's existing balance, and share of the miner is calculated as B times P. So, this constant amount of money is given to every individual miner who is joining in the pool, and in this particular architecture paper share, the miners get almost equal payment, but the risk is at the pool operator. So, it may happen that the pool is not able to find out any new block, but because this is a kind of instant payment and a guaranteed payment to the participant or to the miners who are participating in this pool, it may always happen that the pool is not getting any reward, they are not able to mine any new block, but still the operator need to pay to the individual miners who are there. Then there are methods like Proportional share, in case of proportional share, the miners earn share until the pool finds a block. So, at each of every mining round, whenever the pool is finding out a block, you find out that what is the total share of the individual miners. So, the share by share we mean the near optimal solution that the miners are able to find out. Assume that capital N is the total amount of shares in the round, and small n is the amount of the share of a particular miner. So, you divide the block reward in proportional to the amount of share that has been generated by the miner in this current mining round. So, a mining round means say this is the time instant. At this particular time instance, this pool has generated a block, and again say at T1, at T2 the pool has generated a new block. So, within this time duration we compute these shares, and in proportion to that share the total mining reward is. So, the pool is generated a new block means at this time the pool gets some reward B. This reward is distributed among individual miners in the pool. Then we have pay per last n share, PPLNS. In PPLNS method, it is similar to the proportional share. The only difference is that here in capital N we are considering the amount of all shares in the round. In case of PP in the next method, we consider only the last n share. So, among the last n share, how much share was obtained by a particular miner, and that way the miner get more profit. So, in that way, if your round is small, that means if you can quickly find out a new block, so you will get more share in this particular paper last n share method. So, the advantage of mining pool is that small miners can participate in a mining pool, and you have a kind of predictable mining, like whenever you have large amount of miners who are participating in the mining procedure, you can say that well there is a high probability that the pool will be able to find out a new block. But the problem with this kind of architecture is that it leads to centralization. So, if you look into this blockchain.info website, and if you look into these blocks, recent blocks which are being relayed by multiple miners, you will find out that the same miners is relaying multiple blocks one after another. So, this BTC.com is relaying multiple blocks. Similarly, via BTC is also relaying multiple blocks. So, all the blocks that are getting relayed, they are actually coming from they are coming from some fixed number of mining pools, either via BTC or say via BTC or BTC.com, again via BTC. So, a notion of monopoly you can be seen with this architecture. And it also discourages the miners from running the complete mining procedure, because it may happen that the miner, well, if they have able to generate some four almost complete block or almost complete hash or near optimal hash, they are happy that well they are going to get some amount of share. So, they may not participate further in the future. Well, in summary, till now we have looked into the permissionless or the open model for blockchain. So, we have looked into the permissionless or open model for blockchain, where any user can join the network and participate in the transactions, and Bitcoin is developed based on this principle. So, the blockchain, it provides a backbone of the permissionless digital currency by providing a decentralized architecture and by providing architecture which is tamper proof with the help of hash chain based technology, and then this mining procedure in a permissionless blockchain, it ensures the consensus in the system. So, that is the broad idea of this permissionless blockchain architecture. So, in the next week classes, we will start with another model of blockchain which is called the permission model of blockchain, and we will see that how traditional distributed system algorithm becomes more powerful for permission blockchain environment, and then from there we will look into different application of blockchain apart from the financial domain. So, see you again during the next class, and thank you very much for attending.